So this is the program which we are going to discuss for the today's class now. Write a program to find the sum of first 10 integer numbers. So this is an assembler directive. Just by looking at its indentation, you can say this is either an assembler directive or an instruction. But area is not an instruction, it is an assembler directive. And this is the name. Sum is the name what we are giving. Code is another assembler directive. Read only is another assembler directive. And then entry, what we have written here is a label. So by looking at the position where entry is written, we can say that it is a label because it is written without any indentation from here. And this can be any name. Sometimes just to indicate this is from the point where your program is starting, we write, sometimes we write it as start and sometimes we write it as entry. And this is not necessary. Okay. It's not mandatory that always you should write something called as entry or start. So if you would like to write something, any other name also you can write. It is not mandatory. So but I have written here as entry and this is not required. And then since it says sum of first 10 integer numbers, so move r1 comma 10. So I'm loading the 10 to the register. I'm moving the value 10, immediate number 10 to the register r1. So because we got to find the sum of first 10 integer numbers. When I say first 10 integer numbers, it is 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. So some of these numbers we got to find. So we make use of a loop here. Okay. So what we are doing, so we are taking the count. Since I got to find the sum of first 10 integer numbers, I'm taking the count 10, okay, because I got to find 10 sum of first 10 integer numbers. I'm moving it to the register R1. And then R2, another register I'm taking, I'm just emptying that register. Okay, I'm initializing that register with the value 0. Okay, so R1, I'm initializing it with the value 10, and R2, I'm initializing it with the value 0. Okay, next. Now why I'm taking initializing this with the value 0, because I'll be using this register R2 in order to store my result. Okay, the result of what addition. So for that purpose, I make use of R2. I'm just clearing that register because if there is any Cheng value or some previous value which is present here, I don't want that. So I'm just trying to clear that. So it's something like when you're writing C program, you initialize a variable to 0, right? Say for example, I need to find the sum um, of 10 numbers and I want to write a C program. I take a variable with the name sum and I initialize it to 0. And within my loop, I go for increasing the value of the sum. So initial value, I'll make it as 0. So same thing what we are doing here. In the register, I'm taking the value. In our register R2, I'm taking the value. And then I'm writing a loop here. This is again a label. Now just you can observe here. So within this loop, so I'm writing add R2, comma R2, comma R1. Now R2 is already 0. So this is where this is something like the register R2 is something like sum right now. Okay. So 0 plus R1. R1 is how much right now? I've initialized it to 10. 0 plus 10. And the result addition 10 goes to the register R2. So within addition instruction, you can use the same source instruction for source register as the destination register. So 0 plus 10 and the result goes to this. So it is something like sum is equal to sum plus 10. So what you people write in C programming language, same thing what we are doing here. So R2 is equal to R2 plus R1, something like that. So now R2 gets updated. Okay. Next. So I'm done with adding 10. Okay. To the register uh, R2 and the result is stored in R2 here, same register. Next, what I do, I go for subtracting 1, R1. Okay. So because I got to repeat it for how many times? So still I got to repeat it for 10 times. So 9 times. So sub s, so this prefix x, yes, I mentioned you in the previous class. So when I want my conditional flags to be affected, okay, so then I mention yes. So when the prefix s is added, the conditional flags gets affected. So here I want the zero flag to be get affected. So and can you tell people tell me when zero flag will be affected? I explained all these things in the previous class. So when zero flag will be affected?
When the result is 0.
Yes. Affected. So can you hear me?
So your voice is breaking a little bit.
Yeah, when the result of the most recent operation that is performed by the ALU is 0. Now what I'm doing, I'm using the suffix yes. Yeah, whenever R1 becomes 0, so I want the 0 flag to be set here when the result of R1 becomes 0. I'm using this suffix yes. So
So your voice
decrement
is
R1
breaking.
by and B and R1 goes 0. So the moment R1 goes 0, yes, yes. Hello. Yeah, please.
Sir, your voice is
You
breaking,
have any
sir.
doubt? Voice is breaking. Okay. I don't know where it got disturbed. So I can repeat from that point.
So from the 0 flag.
Okay. See here. See, I'm adding the content of register R2 with R1. Okay. And the result goes to this R2. So I've added 10. Okay. Next to add is 9. I need to add the number 9. What is that I got to do? From this R1, I need to subtract 1. Sub, so it is not only sub, it is sub as I'm writing. Why? I'll tell you. R1, comma 1. I'm trying to subtract 1 from the R1. If I subtract 1 from R1 will become how much? Flags to be affected. In the previous class, I explained the conditional flags when we were discussing that register CP SR register, current program status register. So the conditional flag negative flag 0, what is that, overflow flag, and then one more. So negative 0 overflow, and one more was there. Which flag is it? Negative four flags totally. Negative flag is 1, 0 flag is 1, overflow flag is 1, and there was one more.
Carry flag.
Suffixes. So yeah, carry flag. Other one was carry flag. So whenever use suffix s here, when the value of R1 goes 0, the 0 flag will be set. That is required for which is a conditional branch statement. So what is BNA is branch on not equal. Okay. So NA is not equal. Branch on not equal to loop here. So just come back to this statement and repeat the execution of this statement as long as the 0 flag is not set. And this BNA, whenever this BNA is executed, it will go and check the 0 flag. If 0 flag is not 0, sorry, not 1. If 0 flag is 0, then what it will do? It will repeat the execution. The moment the 0 flag is set, so when the 0 flag is going to set, or when the 0 flag is going to become 1, so the moment R1 value goes 0, then it will come outside this loop and it will end the code. Hope people understood with this.
Yes, sir.
Okay, so just load the value 10 to the register R1, initialize the sum to 0, and then add the sum R2 with the 10, and then the result is in R2, and then keep subtracting 1 from the register R1, and we have used the suffix as, and this is going to update the conditional flag. So we are interested in 0 flag here. Okay, so as long as this R1 is not 0, we don't have the 0 flag set. So 0 means 0 itself. So as long as the zero flag is 0, so this BN will make repeat the execution of these statements. When the zero flag becomes 1, so it comes out of this loop, and then we are saying be back and then end. So this is what the program is. We'll try to execute this now. So project, so new microvision project. I'll go to desktop. Okay, I'll create one more folder. Lab. So inside this, let me create another folder with the name lab1, sorry, lab2. Now I'll give here lab2 as the project name. Clicking on save, LPC2148. So startup.s is not required. Come here. Okay, file, new file. So we write the program now. Okay, so I'll write the comment line. So program to add first 10 integer numbers. Okay, now area. So now let me save the program. So I'm saving it inside the lab2. Again, I take the name of the program also as lab2.s. Area sum code read only move R0 comma to the register R0. I'll move the 10 and move R1 comma. You can use any registers. I'm not sure I'm using the same register which was showed in the program. Okay. To this I'll move 0. I'm initializing it to 0. Okay. Next. Right loop. Then add R0, sorry, R1. So because I want the sum in the register R1, comma R1, comma R0. Next, what we got to do? Yeah, tell me. So what I have to do next?
Sub s r1 comma hashtag 0x01.
Yes. Hello, can you hear me?
Yes, sir.
Hello, can you people hear me?
Yes, sir.
Yes, sir.
Okay. So what is the next statement? What is that I need to write here?
So sub s.
Yes, I need to subtract 1 from the register R0. Okay, sub s R0, comma. Why I'm using sub s? Because I want the conditional flags to be affected. So if I'm not writing this suffix s, then the conditional flags are not affected, and then you'll not be able to use the branch instruction. Okay, now I need the suffix s. R0, R0, comma 0x01. Okay, this is what I'm subtracting. Next, What is that I need to do? B any branch or not loop. And then back B back. So anything to ask? Shall we go with the execution? Say to please respond, unmute and respond. Shall we
Yes,
go with the
sir.
execution?
Yes, sir.
Okay. We'll add this to the source group 1. Yeah, thank you. I'm adding it to the source group 1 now. Add, close. Okay, so it is added. lab2.s is added. Now I go for translating it. So translate it. Okay. It says warning in line number 7. Seen before the constant. Oh, here, sorry. So you got to add this hash. Whenever you are writing an immediate number, hash is required. Okay. Now, so that warning is gone. 0 errors and 0 warnings. Build the program. Okay. Now I'll go for debugging. And my network quality is good, I guess. Is it still breaking my voice?
No, sir.
Okay. So now just observe here. I'm pressing F11 now. So we are moving the immediate number 10 to the register R0. Now R0 will get A. See, R0 is A. Okay. Now I'm moving 0 to the register R1. It is already 0. Again, we are making it as 0 to be in a safer side. That's all. Okay. So R1 is again 0. Now add R1 comma R0. R0 is 10, that is A, and R1 is 0. Okay, 0 plus A is A itself, and that is what you will see in the register R1 right now. So R1 gets the value A. So R1 is A right now. And next, we are subtracting. Let me expand this CPSR. Okay, so this is negative flag, zero flag, carry flag, overflow flag, and this is your slow interrupt, fast interrupt, and then thumb bit, and this is your mode bit. Okay, so now our focus is on this right now, zero flag. Okay, now what is that I'm trying to do? From R0, I'm trying to subtract 1. If I subtract 1, it becomes 9. R0 becomes 9, and that 0 is not 9 is not 0. So you don't have the 0 flag set to 1. It will remain as 0 itself. Observe now. So I subtract it. You can see R0 is 9. And what about the 0 flag? 0 flag is still 0. Okay. So when the moment you use the suffix s, it will update flag. So our focus should be only on the 0 flag right now. So 0 flag is still 0. Now branch are not equal to loop. Now what this BNA will do, the BNA will examine the 0 flag. So as long as the 0 flag is 0, it will loop back. So we are checking not equal, right? So what this not equal condition will do is, so this is going to jump to the loop until the 0 flag is 0. The moment the 0 flag becomes 1, it will come out of the loop. Okay. Now, if I press F11, okay, so I'll show you in the assembly code as well. See now, here, so BNE, and this is the loopback address. Where it will come? See, this is the address. This is the address of this BNE instruction right now, and B and E, I've written loop. Where is that loop? It goes back to the address 8 here. It jumps back to the statement and repeats the execution of the statement. Hope you people are following.
Yes, sir.
Hello. And what is this? So this is the address of BNE, and this is the address of loop. It goes back here. Now what is this? And what is this? And what is this? What are all these things? This column is what?
Instruction.
Correct. So this move R0, 10 is the instruction. What is this right now? You tell me what is this? I've already told you in the previous classes. Mission code. Mission code. This is the mission code, and this is only for our understanding. So this is what I can understand, but what CPU can understand is this. Correct, no? So this is the mission code for move R0, A. Okay, and this is what is understandable by the CPU, and this is only for our purpose. Okay, now let me move back. Okay, now if I press F11, so if I press F11, you can see here it jumps back to this. It comes to this instruction again. F11, see the arrow, we are back here. Okay, and you can see the program counter also. It has come to the address 8. So let me come here and show you. See, this yellow line is pointing where? Here. So it is shifted. Now we'll continue. Okay, so if I press F11 now it has 9 with A. Okay, so 10 plus 9, it is 19. 19 in hexa. How much is 19 in hexa? For 16 it is 10, 17 it is 12, 18 it is 13, for 19 it is 14. Now in R1 you should get the value 14. Okay, people are following?
Yes, sir.
Okay. Sorry, 13. So it is 13. So 16 it is 10, 17 it is 11, 18 it is 12, 19 it is 13. So you got the result 13 in register R1. Now again you're subtracting 1 from R0. R0 was 9. Now subtracting 1 more from it gives you 8. Okay, so 8, and still you can observe 0 flag is still 0. Now again it will loop back. Okay, now so added one more time, 7 is added and the result is 1B now. So let me go. Okay, so keep observing the value of R0. R0 is 7 right now, and 6 right now, 5 right now, 4 right now. 4 is added, 3. So 3 is added, and now 2. Observe here, 2. Now 1. Okay, so now 1 it is. So we're adding 1. 1 is added already. No, 1 is not yet added. So now it is getting added. So 1 is added. Now the result is 37. Now 1 minus 1 it is. Okay. Now when this statement sub as executes, you can see the 0 flag will become 1. Why? Because 1 minus 1 is 0. The result in register R0 will become 0. The moment the result of any recent operation that is performed by the ALU goes 0, the 0 flag will be set to 1. So I press F11 now. Observe now, the result in R0 is 0 and the 0 flag is set. Now branch are not equal to loop. This condition is false now. Now it will come here to back B back. So now we are in back B back. Hope you understood. Is that clear?
Yes, sir.
Okay. So now this is what the sum 37 in hexa. Okay. So let me open the calculator. So I go to this. Okay, decimal only will take. So what we did, 10 plus 9 plus 8 plus 7 plus 6 plus 3 plus, sorry, not 3, 6 I did, 5 plus, and then 4 plus, then 3 plus, 2 plus, 1 plus. So 55 it is. So 55 in hexa. Oh, sorry, I think I made a mistake. So let me clear all. So let me do hexadecimal itself. A plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. How much it is? 37. I did hexadecimal addition. It is 37. You can do decimal also, and you can in between I missed something, so it was not proper. Okay, 55, and you can convert that into hexa. You'll get it as 37. So hope the program is clear. Okay, so now let me execute this program without adding the suffixes. Okay, I don't want the suffixes. Now if I don't add the suffixes, so conditional flags are not affected, and BNE will not work. For BNE to work, the conditional flags are required. So the moment, see, one more important thing is whenever you do the change to the source, okay, save the program, you got to translate it again. So, and many students forget to do this. Okay, so now even I can go for debugging, and if I debug, what it will execute my earlier instance, so the previous instance. Okay, so when you do the changes, don't forget to translate it again and build it again to get the new executable file. Otherwise, it runs the previous executable file itself. All the changes what you have done and saved will not be taken into account. Okay, or it will not get affected. So I'm translating it again. I'm building it again. Now I debug. Okay, so let us quickly go through this now. R0 and 0 I put to the register R1, R0 with the 10 and R1 with the 0. Now I'm adding. Okay, this is fine. Now I'm subtracting. Let me expand this CPSR. Okay, I'm subtracting. See, so earlier the carry flag used to get affected, right? Now nothing has happened. That means the conditional flags are not getting affected. Okay, and you don't have any instruction using which you can go for directly looking into the content of the register whether it is 0 or not 0. So all this you got to check by looking into the conditional flag registers. Okay, these are the conditional flag registers, and for that purpose the adding suffixes, whenever you got to repeat something and whenever you feel like you got to execute a branch instruction based on the result of the previous operation, so it is always necessary to add the suffixes in order to update these conditional flags, and all this branch instruction they act based on the conditional flags. So I'll just let us proceed. F11, say subtract. Again I subtracted, so there is no conditional flags getting affected. Now 4, 3, so this is what I'm saying now. Now it is 2, now 1. Okay, now it becomes 0. So it is 0. So but where is the conditional flag? 0 flag is still 0. Now what it will do? Again it will loop back. Loop back, add 0 to it. Now subtract. Now when you subtract, so what happens? What was the value? 0, 0, 0. It wraps around. It wraps around. The minimum value in the register that it can hold is 0, 0, 0. When you try to subtract 1 from the 0, 0, 0, it wraps. It wraps to the higher value, that is F, 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 F. Again, when you subtract one more from this, it becomes F, 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 E. OP people are following? Hello?
Yes, sir.
it wraps around. See, I'm going now again for the next thing. Now subtract, add this, okay, and subtract 1. Okay. Now what happened now? This is a negative number. Okay. So whenever the most significant bit, 31st bit is 1, it's a negative number. So I subtracted it. How much? 37 it was. Now it become how much? 36. Okay. Now F11 I'm pressing. Now how much is this? E. Okay. So back count. It is coming from the higher value in the backside direction. And but what is this right now? This is a negative number. Okay. So it's something like this, 37 minus, 36 minus 2, something like this. Okay, it is doing. So I guess you people understood the importance of adding the suffixes and the importance of the conditional flags whenever you're writing the branch statement, conditional branch statement, something like this. Okay. Okay. We'll stop here and you'll understand in detail all this conditional branch statement. This is branch on not equal. So there is something called as branch on equal also. Okay. You understand. I mean, there are many conditional branch statements, something like this. Gradually, you keep understanding one by one. Okay. Let me minimize. So if you have any doubts, you can ask me. So the program looks simple, but there is a lot to understand. Okay. I guess you have understood all those things. Yes or no?
Yes, sir.
Okay. Now, so this is just a snapshot of the execution. Okay. And who doesn't know this? Write a program to find the factorial of a number. You have already done this. If I say 5 factorial, it is 5 into 4 into 3 into 1. And you get the value, and you already know how to write the C program to find the factorial of a number. And that too, you know how to write a recursive function in order to find the factorial of a number. Now the same thing we are going to implement it using the assembly code now. Okay. Um, so even the C program which you write in assembly code, and when it is translated in machine code, it's the same thing. It comes to this basic form. Okay. So all these days you were writing the high level program and you were not knowing how the getting done inside the CPU. So now you've gone very close to the CPU and understanding how all the programs which you wrote earlier, in the high-level programming languages, how they were performing their execution inside the CPU, with the registers. So that is what programming language. I know the logic already. Now, what is the point in learning this? So that time when you wrote the C programming language for finding the factorial of a number, you're not knowing how all the things are getting done inside the CPU. So now you have gone very close into the CPU and you're understanding how your CPU is performing all this computation. So no matter in which programming language you write the logic, whether you write it in C programming language or whether you write it in Java, whether you write it in Python, whether you write it in Dart programming, some other programming language, if you know. Okay, ultimately, it is this way the computations are done within the CPU. Okay. Okay. So please copy this. Copy this. See what we are doing here. Again, the code area. I'm giving the name of the area as factorial. So entry start. I said this two are not necessary. Now move R0, 3 I'm writing. This is the number whose factorial I need to find. Say for example, I need to find factorial of 3. So this is what I'm moving it to the register R1, R0. And then so this number I'll change to 5. And then what I'm doing, of So can you see my screen? Am I audible?
Yes, sir.
Yes, sir.
I think I have okay, I'm backing it up. Okay, and next what I'm doing, I'm subtracting one. Okay, see R0 I'm not touching. So I have it here. I've taken one more copy of value in register R1. That is what I'm subtracting. So R1 minus 1 subtraction I'm doing. Okay, and I'm using so yes also here suffix because I want my conditional flags to be affected, and then I'm comparing. Okay, because I want to stop this where say for example 5 factorial when you're finding 5 into 4 into 3 into 2 into 1, and I should not go to 0. If I multiply it with 0 and again everything becomes 0, anything which you multiply by 0 is 0. Okay, so I want to stop the process when it becomes what 1. I don't want to go till 0. Now I'm taking one more compare instruction. I'm just trying to compare the value of the register R1, okay, with 1.
So your voice is not
So
audible.
can you hear me? Breaking. Yeah, I'm getting it as on hold. So whenever the network issue happens, something like this. Sorry, I have Act FiberNet 150 Mbps. I don't know. Can you hear me now?
Yes,
Am I
sir.
audible? So please, one of you unmute and speak.
Yes, sir.
Can you hear me now? Okay.
Yes, sir.
Yeah. For this instruction, yeah, thank you. So for subtract instruction, so here yes is not necessary, but I have written it. So it doesn't make any difference. Okay. So but it's not necessary. So because compare, what it will do is, so when I compare the content of register R1 with 1, if they are same, then again it's going to affect the 0 flag. Okay. So equal to 2 stop. If the content of this R1 and is same as 1, then I see branch on equal. In the previous program you understood branch on not equal. Now the condition what I'm checking is branch on equal. If R1 is same as this 1, then come to stop here and then say back be back. Otherwise what I'm doing, if R1 value is not 1, next what I do, I multiply R0 with R1. What is there in R0? In R0 you have the original value, that is 3, and in R1 you have the subtracted one. How much it is? 2. 3 into 2. Hope people are following.
Yes,
Hello.
sir.
Yeah. So R0 you have 3. In R1 you have 2. 3 into 2. Okay. 6. 6 goes to register R3. Next what you're doing, move comma R3. Move R0 comma R3. So the 6 result which you have here, you're moving it to the register R0. Now R0 is 6 right now. And then branch on not equal to fact. Okay. So factorial, come here. Okay. I'm just checking whether the result of the previous operation, which is the this R1, okay, not equal to 0. Now I go back here because this also affects the conditional flag 0 flag. So branch and not equal to fact, and I subtract one more from R1. What was the previous value of R1? It was 2. Now 2 minus 1, it becomes 1. Now again comparing R1 branch on stop. Anything multiplied by 1 is the same thing. 6 result I've already got. 3 into 2, I've got 6. So I need not multiply this 6 into 1. That is not necessary. The moment R1 becomes 1, branch on equal to 2, stop. Come here and say back P back. So people understood with this, and next class we'll go for executing this. Is that clear?
Yes, sir.
I will. Okay. So when you're executing, you'll understand still further in detail, because you'll observe the content of the registers, and you'll get an idea how it is working. Okay. So this compare, okay, is supporting the execution of BEQ and also supporting the execution of BNA fact. Now what I'll try to do is I'll try to execute this program by having this yes suffix for subtract instruction and without having. Okay. So because this is not necessary, because this is the one which is the most recent operation which is going to affect the conditional flags, and still if you use yes also, not a problem. Okay. Okay. So we'll stop here. I guess all of you have copied this program. Don't execute this for today if you have labs or this week. So I suggest you people to finish executing the 4 sample programs, and first 2 programs you can finish, okay, in this week. So we'll have this for the next week. Okay. So thank you. So let me download the attendance. So it is still 46. If you have group, please inform them. So around 70 is the strength. 24 students are absent. So say every week, Saturday weekend, we're uploading the same thing. So what I'm saving the attendance, right? The same thing is getting uploaded to the VTU. So they have shared as a form. So subject wise and faculty wise, we are updating it. In case if they don't, so everything is tracked. So at the end, I cannot give you simply the attendance. So the minimum required, say, because it is not new now. So it is almost 1.5 year. So they are expecting the students to participate in the online classes. Okay. So if the same thing continues, I'm just going to mark and call all those people who are not attending and who don't have the required attendance, and they'll not be given the attendance. So because at the end, it will be very difficult for me because everything is uploaded. So every weekend for Saturdays. So that is our first job, what we are doing. So we are uploading the status of the classes and the attendance status. Whatever I'm downloading here, the same thing is getting uploaded to the VTU. Okay, thank you. We'll meet again tomorrow. Thank you.
Thank you, sir.
Thank you.
Thank you.